Question number 6. This question is of kinematics of motion in a straight line. Kinematics of motion in a straight line. In this question, there are two concepts. There are a concept of differentiation and integration lies in this question. The topic is kinematics of motion in a straight line. We use here the concept of differentiation and integration. A particle P starts at rest. At rest, mean initial speed will be 0 and moves in a straight line from a point O. At time t second after leaving O, the velocity of P v meter per second is given by. This is the velocity time relation. V is equal to Bt plus Ct t power 3 over 2, where B and C are constants. P has velocity 8 meter per second when t is equal to 4 and has velocity 13.5 meter per second when t is equal to 9. To show that part A of this question, show that B is equal to 3 and C is equal to negative 0.5. We have to find the values of these constants B and C by using these conditions. This is the relation between V and T. V is equal to Bt plus C T power 3 over 2. Now velocity is 8. This is the condition. Velocity is 8 when T is equal to 4. Velocity, these are the conditions. V is equal to 8 when T is equal to 4. V is equal to 8 meter per second when T is equal to 4 seconds. The other condition is when V is equal to 13.5, T is equal to 9. Now we will put these two values separately. V is equal to 8, T is equal to 4. We are putting here. We will get an equation in V and T, B and C, and again we are putting this set of values V and T. We get another equation in B and C. We will solve these two equations simultaneously. First, we are putting this set of values V is equal to 8, T is equal to 4. We get this 8 is equal to B into 4, T is equal to 4 plus C into 4 power 3 over 2. Now simplifying it, we get uh, 8 is equal to 4B plus 8C, because 4 power 3 over 2 is 8. So we will write here 8C. This is clearly this equation is in B and C. Further, we can simplify it because all the terms are multiple of 4. We can divide each side by 4. We get it 2 is equal to B. We are dividing each term by 4. 2 is equal to B plus 2C. This is equation number 1 for reference. Now similarly, we are putting this set of values in the same given relation. We get another equation in B and C, putting this second set of values. We get 13.5 is equal to B into 9 plus c into 9 power 3 over 2. We have put the values of b and t in this equation. We get this equation. Now we will simplify it like this. We get 13.5 is equal to 9b plus 20. 9 power 3 over 2 is 27. So we will write here 27c. Now all the terms in this equation are multiple of 3, so we can divide each side by 3. This will become 4 point. This equation we are dividing this whole equation by 3 because all the terms are the multiple of 3. So we get 4.5 is equal to 3b plus 9c. Let this is equation number 2. Now solving these two equations simultaneously. Now we will solve these two equations, both equations involving b and c. We can use substitution method or elimination method. We can get these values of b and c. So from here we can get b is equal to 3 and c is equal to 0 minus 0.5. You can solve these two equations simultaneously to get b is equal to 3, c is equal to minus 0.5. Now, part B of this question is find the acceleration of p when t is equal to 1. Now, first of all, we will put the values of b and c just we have found in the equation b and t velocity time relation. We can also say that this is a velocity time relation. B is equal to 3t. Put in the values of b and c. This equation will become b is equal to 3t minus 0.5 t power 3 over 2. Now we have to find the acceleration of p at t is equal to 1. So first of all, we will differentiate this. Since this equation is in b and t, we will differentiate velocity with respect to time. We get acceleration. So we can write it as acceleration is equal to dv over dt, which will be equal to 3 minus 0.5 into 3 over 2 power of 3. Power of t will be decreased using a differentiation process. 3 over 2, 3 over 2 minus 1 we will write here. So this becomes power is 1 over 2. Now this is the no t is given, that is t is equal to 1. Now we will find the acceleration when t is equal to 1. So putting here t is equal to 1, 3 minus 0.5 into 3 over 2, t is 1, 1 power 1 over 2 remains the same. So after calculation, we get the acceleration is 2.25 meter per second square. This is the answer. This is the acceleration of the particle p when t is equal to 1. Now part C of this question is find the positive value of t when p is instantaneous rest and find the distance of p from O at this instant. Find the positive value of t when p is instantaneous rest. P is at instantaneous rest mean v is equal to 0 at this instant. V is equal to 0 when P is at instantaneously rest. So we can write V is equal to 0. So V is this 3t minus 0.5 t power 3 over 2. This means that uh, 3t minus 0.5 t power 3 over 2 is equal to 0. From here we will find the value of positive value of t. So first we can write 3t is equal to 0.5 t power 3 over 2. Now by cross multiplying process we can write that 3 over this 0.5 will comes on the left side in the denominator. 3 over 0.5 is equal to the right side 3 over 2, and this t by cross multiplying will come down in the denominator. So over t. So left side 3 over 0.5 is 6. In the left side there is in the denominator t is t power 1, t power 1. So we can write that 3 over 2 t power 3 over 2 minus 1 t is equal t power 1 over 2. So t power 1 over 2 after simplifying it. Now we are taking we will take scale each side to find the value of t. So when we scale each side, we get t is equal to 36 seconds. This is the positive value of t. And find the distance of P from O at this instant. This means that at this instant, at t is equal to 36, we have to find the distance of P from O. Now, to find the distance, we will integrate a speed with respect to time. To find the distance from speed, speed is this. This is speed, and we will integrate the speed with respect to time to get distance. So since v is equal to 3t minus 0.5 t power 3 over 2, integrating each side with respect to t. So when we integrate left side, that is v, when we integrate v with respect to t, it will become s for distance. Right side will be integrated with respect to t, 3t minus 0.5 t power 3 over 2. Within bracket we will write here dt. dt means with respect to t we are integrating this. So integrating, and limit is distance of p from O. P is the particle, p from O means this is O. This this is O. Particle is moving in this direction. Here t is equal to 36 and v is equal to 0. We have to find actually this distance. Here the limit at the starting point speed is also 0, and at t is equal to, here time is equal to 0, here the time is 36. So we will take limit 0 to 36 here, 0 to 36. So limit is 0 to 36. Now we are integrating 3t, integration of 3t is 3t square over 2, 3t square over 2 minus 0.5 remains as such because it is multiple. We will add 1 in the power and in the denominator, same is in the denominator as the power of t. So and now we simplify it. Limit is 0 to 36. Now we will simplify these terms. We get s is equal to 3t square over 2 minus 0.5 t power 5 over 2 over 5 over 2. Limit is 0 to 36. Further simplifying it, these two terms, we get uh, 3t square over 2 minus 1 over 5 t power 5 over 2. Limit is 0 to 36. First we will apply the upper limit, then lower limit. First we put 36 in place of t, then in place of t we will put 0. This is the way to apply the limits, upper limit minus lower limit. Then s will become, putting t is equal to 36 in the question, 3 over 2, 36 square minus 1 over 5 into 36 power 5 over 2. This is upper limit, and lower limit, since lower limit is 0. So when we will put in place of t 0, then these two terms will be 0. So uh, here is lower limit is 0. So this is 0. Now simplifying this, we get finally the distance will be the answer of the first term, and the second term we will subtract using calculator. Calculator we get this after calculation. First term will be 1944, and second term 1555.2, and finally the answer is 388.8 meter. This is the answer. And now the next last part of this question is, find the speed of P at the instant it returns to O. Find the speed of P at the instant it returns to O. First the particle starts from rest from O on this side. Now it returns to O. This means that displacement will be 0. Displacement will be 0 in this case. So first we will find the time, and then we will find the speed. Find the speed of P at the instant it returns to O. S is in displacement is 0. So first we will find, putting S is equal to 0, we will find the values of T. So distance is, just we have found the distance, that is, this is the distance after simplifying. This is the distance. Distance is equal to 0. So 3t square over 2 minus 1 over 5 t power 5 over 2 is equal to 0. From here we will find the value of t. So we can write it as 3t square over 2 is equal to 1 over 5 t power 5 over 2. Now by cross multiplying we can write 3 over 2 into 5 over 1 on the right side, 5 t power 5 over 2 divided by t square. Now simplifying we get 15 over 2 is equal to t, right side will be, after simplifying, will be t power 1 over 2. Taking square each side we get t is equal to 225 over 4 seconds. Now at this instant we will find, uh, at this instant 225 over 4, we will find the speed. Since the speed is in the above part, B is 3t minus 0.5 t power 3 over 2. Now putting in this relation, t is equal to 225 over 4, we get the value of V. So V will be 3 into 225 over 4 minus 0.5, t is 225 over 4 and power is 3 over 2. We use here the calculator. We get V is equal to 168.75 minus the calculation of, after calculation, this the value of the second term will be minus 210.9375. Now finally we get V is equal to negative 42.2 meter per second, but we will take only the magnitude of the speed. We are not taking this sign of negative. We just show that the speed is 42.2 meter per second. This negative sign of the speed is shows just the opposite direction of the particle. First, the particle moves on this side, then on this side. Opposite side, the this negative sign shows the opposite direction of the movement of the particle. So the speed at this instant 225 over 4, the speed will be 42.2 meter per second.